Hello everyone, let's talk about excuse me, scientific notation for a little bit. Scientific notation is a way to write very large and very small numbers in a more compact way. Excuse me. So there are 1 billion seconds in 30 years. We can either write 1 billion as a 1 with 9 zeros or 10 to the 9th seconds. Which way is faster to write? Well, 10 to the 9th. People say that you have a 1 in a million chance of winning the lottery. A 1/millionth chance can be written as 0.000001 or 10 to the -6. Once again, which is faster to write? This. Okay, so using powers of 10 to write a very long number is very much more manageable, and that is called scientific notation. But there are specific rules that go along with it. Okay. So here is scientific notation. You are going to have a number A times 10 to a number, where A is between 1 and 10, and N is an integer. Okay, and an integer just means a number, 1, 2, 3, -6, no decimals, no fractions, or anything like that. Okay, so to write a number in scientific notation, if you start with a number, you're going to move the decimal left or right. You need to have one digit to the left of the decimal. So here this is 17 trillion, or 17,345 billion. And we can write it out like that, or we can write it as 1.7345 times 10 to the 13th. Here, I can take this very, very small number and move this decimal over here using powers of 10, and it becomes 1.75 times 10 to the -15th. This number tells you how many places you are moving the decimal. So here, I moved it from here. I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. Oh, I had to go to the 1, so 13 places. Here, I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And again, in both instances, I have one digit to the left. It doesn't matter how many are to the right of the decimal. Okay. Numbers that are larger than 1 use positive powers of 10, and numbers that are small use negative powers of 10. Now, to kind of demonstrate this, and I put this on Blackboard, is a chart of some powers of 10. So 10 to the -6 is 0.000001. Written in scientific notation, it's 1 times 10 to the -6, and that is a millionth. Okay. Notice you're starting at a small number, -6, -5, and notice all of these numbers up until you get 10 to the 0 are all smaller than 1. So anything with a negative exponent is smaller than 1. Anything to the 0 power is 1. And then as you get larger and larger, these positive exponents, notice the exponent corresponds with how many zeros there are after the 1. Okay, and then here are the names again. And we'll talk about this in a second when we look at our calculators, but you'll want to know how this will appear in your calculator. And that's going to be a little bit different for everyone. Okay, so we want to be able to write numbers in scientific notation. All right, this number here, this is the diameter of a nucleus of hydrogen. 1.8 times 10 to the -15th. Carbon, notice I want the decimal right here where there is one digit to the left, which means it is between 1 and 10. So I'm going to move this over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 10 to the negative 11. It's a small number. Your exponent is negative. And Celsius, I need to put the decimal, so there is one digit to the left. So this is going to be 5.96 times 10 is going to be a negative number again. And I move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 to the negative 10. Okay. So if we're given a number, we need to be able to write it in scientific notation. If we are given a number in scientific notation, then we need to be able to write it in, well, these are large numbers. Okay, so this number was given before. This is 1.7. Notice, usually it only goes to a couple of decimal points. Don't worry about it too much. But here, since this is a large number, it's going to be a positive exponent, but I am taking this decimal point here and moving it over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If I do this, I can round this to 5.7. If I wrote it out 5.719, that would not be incorrect. I need to move my decimal to right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 10 to the 12th. Okay. All right, then the population or the debt in terms of China, I'm going to do 3.0. And this is going to be a large number, so I need to go from here to here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So once again, that's 10 to the 12th. Okay. Now, to reverse the process, I'm going to write each of these numbers in ordinary notation, or just as a number. Ordinary notation just means you're going to write it as a number. Okay, so if I have 1.2 times 10 to the 6 joules, I have 1.2, and I am going to need to move this decimal 6 places to the right. So I go 1, 2, 3, 4, 5, 6. And that's where my decimal goes. And of course, then I fill in everything in between with zeros. So that becomes 1,200,000. If I want to turn 6.9 times 10 to the negative 3 kilometers into a number, this is a small number, so I'm going to start with 6.9, and I want to take this decimal and move it 1, 2, 3 places to the left, so this becomes 0.0069. Okay, so you're going to be, when you're doing common numbers, you're going to be replacing words with multiplication to a power of 10. And this is all on this chart. 1,000 is 10 to the 3rd. 1 million is 10 to the 6th. A billion, I spelled it wrong, is 1 times 10 to the 9th. And then, of course, 10 to the 12th is a trillion. Okay, and I'll try to fix this. Okay, so if we want to write 2.2 million, we can replace million with 10 to the 6th. An estimated world nuclear energy production is 2,608 billion. So this is 2608 And billion is going to be 10 to the 9th. But note here, this is not in scientific notation. The reason is 2608 is not between 1 and 10. So, if I want to take this number now and turn it into scientific notation, if I want to take this and turn it into scientific notation, I am going to start out with the 2608. So 2608, if I want to turn that into scientific notation, I'm going to take this decimal and move it 3 places to the left, so that becomes 2.608 times, this is a number larger than 1, so 10 to the 3rd, times 10 to the 9th. From here, I can use my exponent rule. The exponent rule is if you have a to the m times a to the n, you just add the exponents. So if I have 10 to the 3rd times 10 to the 9th, this part just becomes 10, 3 plus 9 is 12, and I still have the 2.608 times that. Okay, now I don't know why this spilled onto 2 pages. I think there's something wrong with my printer. In the U.S., in 2000, U.S. health expenditures were 1.4 trillion, and in 2016 the amount increased to 3.3 trillion. Write both of these in scientific notation. Okay, well I'm going to do that on the next page. So 1.4 trillion is 1.4 times, and 1 trillion is 10 to the 12th. $3.3 trillion is going to be 3.3 times 10 to the 12th. Okay, so I want to find the percent increase in healthcare spending. Okay, that means I need to find the relative change and turn it into a percent. Okay, so we want to use, we'll make this our reference value, and this, because we want to find the percent of increase. This is smaller than this, so we're going to do that. So my relative change is equal to my compared value minus my reference value divided by my reference value. Now in your calculator, it's going to be different for all of them. I normally use a graphing calculator. But here's what I'm going to do. I'm going to show you exactly how I would do this if I had another calculator. Remember, this fraction bar is like a grouping symbol. That means I need to take all of this divided by all of this. So in my calculator, I'm going to take 3.3 times 10 to the 12th minus 1.4 times 10 to the 12th. Whoops. Put it in parentheses, and then do divided by, open my parentheses, 1.4 times 10 to the 12th. Oops, I did something wrong. All right, so let's try that again. All right, so let's do 3.3 times 10 to the 12th minus 1.4 times 10 to the 12th. Then I'm going to divide that by 1.4 times 10 to the 12th. I think I missed a parentheses at the very beginning. And this gives me, and we will round it to 1.3, let's go to 357. Okay, so now that I've done that, I have to turn this into a percent, which means I move this 2 places to the right, so this becomes 135.7% increase. Okay, that's it for scientific notation. We will continue on with energy in our next one.